Okay, so if f prime is cosecant squared minus 2/3 x to the 4/5 minus x, what's little f? Okay, so that means we're going backwards, right? We're going from f prime to f. So we need to be able to recognize derivatives of stuff so we can write what the antiderivative is. Cosecant squared. Does anything need to be rewritten, first of all? That would mean like getting rid of any radicals and bringing x's from the bottom to the top? No, the second term, maybe if it were a fifth root of x to the fourth, but it's written already in a nice format, ax to the n. So we got three terms. It's like three individual problems. Here we go, boom, 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 down the line. The derivative of what is cosecant squared? Good, negative cotangent. Because if you guess cotangent of x and you check, and you're like the derivative of cotangent is negative cosecant, you're like, ooh, I got some stomach acid. I need to come back and take some antacid, right? Some Tums. So there's a negative correction there. Minus, for the 2/3, remember, this is the power rule. And this is like the only rule we're going to have. We might have some strategies, but this is the only rule. Ax to the n. Instead of multiplying and subtracting like we did for the derivative, we do the inverse operation in the reverse order, right? We add and then divide or multiply by the reciprocal. So I always put the constant multiple 2/3 goes along for the ride, leave a little space, and add 1 to 4/5. 4/5 plus 1 is 9/5. And now either divide by 9/5, yucky, yucky, gross, gross, right? Complex fraction. We'll just multiply by its reciprocal 5/9. Easy. And then minus x, x to the first becomes 1/2 x squared. And then plus c. Don't forget the plus c. Don't be a statistic. Don't be a meme. Right? Plus c. That's the general antiderivative. If I then wanted you to find the value of c, I would have to give you a point that satisfies f of x. We call that an initial condition. All right. Simplify if you want, but that's all kind of neither here nor there. 6 of one, half dozen of the other. That's the answer to one of the Rebus puzzles. Yeah. Okay. So are there any questions lingering from 4.1? Y'all are comfortable with this, right? The video taught y'all. This is the integral symbol with respect to x. Was it bad? Okay. Well, let me briefly talk about it. So when we see this, we know what to do when we see this, right? This implies action. We have ddx, the verb, which says to take the derivative with respect to x of what follows. There is a verb format too for the antiderivative, and it's the integral symbol, the elongated s. The dx is called the variable of integration, but it's the same dx that's served up here. We had the derivative with respect to x. This is essentially the integral with respect to x. Yeah, we're multiplying. Yeah, the derivative is really division, and the integral, as you can see here, is actually multiplication, f of x times dx, okay? Now, I like to think of the integral and the dx as bookends, right? In between the two bookends, you have what's called your integrand. Integrand is like the radicand, the thing under the radical. This is the thing that you're trying to find the antiderivative of, okay? This is also called an indefinite integral because it's just the elongated s. If you saw like a number or a letter here, that would be a definite integral. That's in the next section. Okay, that's going to mean a definite answer. But without those, your answer is an indefinite answer, meaning it's going to be plus c. All right, so this is now the verb. This is the verb. It says take the antiderivative of what follows with respect to x. And we'll learn in the next section, if you didn't watch the video already, why it looks like elongated s, right? And why it turns out to be multiplication. So let's look at a couple of these. Simplify early and often. Evaluate. You're like, oh, okay. I have the integral with respect to x. Got it. So I need to find the antiderivative of that thing. Does anyone look at that and say, hey, I spy the derivative of so-and-so? Do you recognize that as the derivative of something? I don't either. So what most of anti-differentiation or integration is manipulating the integrand or manipulating the expression into something that you either recognize to be the derivative of, like the warm-up, or the power rule. And so we develop a lot of strategies for manipulating the expression. For this one, I would say, hey, first thing you want to do is rewrite any radical as a fractional exponent. Yeah. And then always look to see if you can have common factors. Do we have any common factors here? In the bottom, I see a 3 that could factor out. So here we go. Let's rewrite it. If you're not going to do it off to the side on your bench, you just do it right here and you got to rewrite everything. 1 minus x squared to the 1/2 all over 3 times 1 minus x squared. This is x squared dx. Okay. Now, because my integrand is a single term, here's what I'm going to be doing the rest of the year. I have a constant multiple of 5/3. Just like when we did antiderivatives, I said throw him in the back of the truck. He's a rider. You can pull him out front of the integral as long as he's multiplied. So that's going to be 5/3 times this. Now he's outside the problem. Like he's literally in the back of the truck. He has no idea what's going on the inside. He's just going to affect the final answer. Oh, there you go. So now the integrand, I can combine these exponents, right? You can combine when you're dividing and the bases are the same. They don't even have to be numbers. They could be binomials, right? Blob to the 1/2 divided by blob to the first. We subtract, then we get what? 1/2 minus 1 is -1/2. All right. Now, can we just jump in and use the power rule? I have something to the negative power. Can I just use the power rule? The power rule works when it's in the form a times x to the nth power. This is a, which is 1 times 1 minus x squared to the -1/2. No, no way. If you tried adding 1 and multiplying with a reciprocal and then took the derivative of that, you're going to get this piece on the first part, but then you're going to have a chain rule that generates a -2x. And you're like, there's no -2x in the integram. So we have to manipulate it into something we can work with or identify. Hey, you ask yourself, is there another way to write that quantity to the -1/2 power? Yeah, it's the same as 1 over the square root of 1 minus x squared. And now you're like, hola, senor. Mason, take it away. Oh, okay, okay. I thought you knew. We're staring at 1 over the square root of 1 minus x squared now. And it's like, that's the derivative of arc sine. Arc sine. Arc tangent does not have the radical. And then plus c. Or inverse tangent, either one. Oh, yeah, who said tangent? I said, yeah, yeah. Mason, I'm trying to make it work for you. There you go. It's arc sine of x. Yeah. Or inverse sine of x. Okay. So it's all about manipulating it into something we can either handle with a power rule or something we recognize. There is no quotient rule for anti-differentiation integration. There is no product rule. Did the video go into the other ones? Yes. Okay. And the volume was okay? I mean, they were definitely a little more confusing. All right. Yeah, they do. They end up being kind of confusing. Like if you look at letter C, let's just look at C. It's 2 terms. So the good news is, like differentiation, we can take the integral of each term separately. We can think of this as 2 separate problems. So I already know with respect to P what the antiderivative of 4 is, right? It's 4P. But here's what I would recommend. If you're going to integrate part of the, you're going to have a higher notational burden, okay? Because you're going to lose points. So let's just go ahead and make everything ready, and then we'll integrate one time all the way across the board. That's what I would recommend. So 4, you just stay put. I need to work on tangent squared. It's got trig in it, so maybe it'll involve trig, right? The derivative of what is tangent squared? Is tangent squared a known derivative? No, I know the derivative of tangent is secant squared, and the derivative of cotangent is negative cosecant squared. But I don't have something that I take the derivative to get tangent squared. But you know what? This is how your thinking goes. When I was going through that mental catalog, the derivative of tangent was secant squared. So if I can somehow turn a tangent squared into a secant squared, that might be a good strategy. Do we have a way to write tangent squared in terms of secant squared? We do. Baby PID number 1, which y'all know from the memorization test, is this. So whenever you see tangent squared or cotangent squared, probably will not happen on the AP exam, but it can. This is still within the ballpark of where they play. You're going to use a trig substitution. And tangent squared, then, if you solve it for tangent of x, is secant squared of x minus 1. And then we have the plus 4 that's just hanging out over there. You need parentheses around your integrand if it's ever more than one term, okay? Because remember, that dx is technically multiplied by every term. So make sure you have parentheses. If it's a single term, you really don't need them. Hey, -1 plus 4, don't tell me, don't tell me. 3, right? So you see why we kind of kept it? Oh, I call it, oh yeah, look at that. I keep using exodus with respect to P. That is a good catch there. Good catch there.
Thank you.
You're welcome. All right, now I have 2 terms, and now I'm ready to roll and rock, right? What do we take the derivative of to get secant squared? Tangent. So that's tangent of P plus the antiderivative of 3 is 3P. And we're almost done. We just need plus C, kaboom. All right. Trig manipulation, trig identities. You need to know them through the double angles. Yes, if you modify, like if you take out the whole, then the integral works everywhere except step 7's not in the domain. That's why we do that. Now you'll see later that we can actually integrate through a hole or a jump, but not a vertical asymptote every time. So it's just customary to do that. If you change the domain, it's customary to warn people on the back end, because some people can get triggered, pretty easily. This one we will have to just pound it out, right? Sledgehammer. This one requires a power reducing identity. This comes up a lot when we do polar area later in the year, but if there's not a lot of power reducing identities on the AP exam, but for what it's worth, right? Y'all remember these. Sine squared of x is equal to 1/2 times 1 minus cosine of 2x. And then cosine squared of x is 1/2 times 1 plus cosine of 2x. So you decrease the power by a factor of 2 at the expense of doubling the angle. And they're both in terms of cosine. The one that's in terms of itself gets the plus sign, because cosine, remember, me, selfish, me plus. And sine's like, whatever, dude, plenty for all of us. So if you were going to do this one, first thing I would do is pull 3 out front. And you got cosine squared of blob with respect to m. So now we can't integrate cosine squared directly, so we use this. So I'm going to do that. That becomes 1/2 times 1 plus cosine of twice whatever x was, okay? It doesn't always have to be cosine squared of x and 2x. All you have to remember is when you half the power, you double the angle. Or when you double the half the angle, you double the power. It's always by a factor of 2, and it's always inversely. So this was m halves up here. I reduced the power by a factor of 2. So I halve the power, I have to double the angle. What's twice m halves? M, right? So that one was designed specifically, to do that. So this is still m halves, but it becomes m right here. Half the power, double the angle. And now the 1/2, you get in the back of the truck with the 3. Okay. And we get down to here. And now it's easy, right? Because now there's 2 terms. We can integrate both of them. 3/2 goes along for the ride. Parentheses. What's the antiderivative of 1 with respect to m? M. And then the antiderivative of cosine. This one's always good. Is it sine or negative sine? It's positive sine. And you know how you know? You just check, right? What's the derivative of sine? Positive cosine. Boom, go me. And then the plus C, should the plus C be inside or outside the parentheses? Or does it matter? Well, technically, if I do 3/2 and there's my integral, this plus C should technically be on the inside, right? But what happens when you multiply 3/2 times an unknown C? You get new and improved unknown C. So when we start going backwards, you'll notice that C has to appear right away. But as we manipulate the expression afterwards, I call C the ShamWow C. You know what ShamWow is? It's a commercial and it's like super absorbent. Like you have a spill, ShamWow. It gets all soaked up in one thing. The guy that does the commercial, he says you could use them on your car, right? Car's wet, ShamWow. The car's gone. The car gets absorbed into the towel. It's that absorbent. Where'd my car go? ShamWow. Okay. The C is going to be able to absorb unknown constants that are added to it or multiplied by it as we go. So anyway, it doesn't really matter. I put it outside. All right. So that concludes 4.1. Any other comments or questions or anything lingering from 4.1? We know what the integral is now. Time to use it. Okay. Let's stop the recording.